Hi guys, glad to hear that you're feeling okay. Thank you, Elena, for the introduction. So I'll keep this short. I'm Dora, this is Lucas. We came all the way from Munich here today, not just because the weather is considerably warmer and sunnier here, because you can't see that down here anyways, but we also came to share some stories of how we use the Atlassian stack for teaching applied software engineering. And what we want to share with you is first, we want to describe what we do, our approach, why we do it the way that we do it, and the problems that we face. Then we're going to go more into how we found the Atlassian tools and configure the stack and configure the workflows and design the workflows to help us overcome these problems and these challenges. We'll do this by telling you about selected use cases that we do in the course, and then we're going to elaborate on the lessons that we learned along the way and find something that hopefully each of you can take away from this talk. But being the good engineers that we are, we're going to start with a problem. So imagine that you're an educator at a university, and the scene that you face regularly at this job is the following. So you have a lecture hall full of students, in our case it's around 100 at a time, and they're all looking at you expectantly with their laptops open, and they really want to hear about software engineering. So what you can do in this situation is you can start talking, hold a lecture, hold the next lecture, hold the next lecture, make them get all the books written by the professor, learn them by heart, make them write an exam, grade it, and never look at it again. And the students would learn a lot from this, a lot in theory. What we wanted to do is find an approach where they learn the theory and then apply this theory in a real project. So we devised a course structure that is built on something that we call the 7 R's. So the basic methodology is we try to create a setting that is as realistic as possible in an academic setting. So we do a Capstone course, which is for mobile application development. We do it twice a year, twice for 3 months, so once every semester. And in this course, the students, they develop mobile applications for a real client, which is a client from industry. It's a company from industry. They do it in 10 projects, around 10 projects running at the same time. And this client gives him a problem to solve. So he says, okay, I'd like to have an application that solves this and this problem, do something with it. And then they collaborate with the client and develop this application in an agile way over the course of 3 months. And they also deliver a real application to their client regularly. So we do this agile methods, we do continuous integration and continuous delivery, and we'll explain all of that a bit more in a minute. But first, I'd like to ask for a show of hands, this picture that I showed before. Who of you has been in that situation in the lecture hall? Who of you has applied theoretical knowledge during their university career in a real software engineering project at university? You're lucky. So imagine the rest of you who hasn't just raised their hands at the second question. Imagine if, for example, during your university career, you had moderated a client meeting or done a sprint planning and a sprint, maybe a backlog estimation meeting or a sprint review with the customer on your own during university. Wouldn't this have prepared you better for your job? And we think that it would have, which is why we do it like this. And we've brought some numbers with us to put this a bit more into perspective. So as I already said, our course has around 100 participants. We do it twice a year. And multiple projects are running at the same time. So we have about 10 to 12 clients who have these problems. They bring them to the students, and then the student teams develop an application for them. Last semester, these were 11 projects. We develop in an agile way using a variation of Scrum that we have adapted slightly. Last semester, we had 72 sprints and over 4,300 commits, so there's quite a lot of coding involved also. This being a development project course, it might not be surprising. All of these commits and lines of code, they went through pull requests, over 1,100 of them. We use pull requests here as an additional quality gate. We let more experienced developers check the work of less experienced developers before a pull request, which can be a new feature or also a bug fix, is merged then back into the main line of the application. So there is this additional check there. And these applications are delivered regularly to a customer, and as you can see here, the customer is also really keen on seeing what the students develop for them. So they download these applications regularly on their phones, they try them out, and they give feedback to the teams instead of the teams just developing for someone who never looks at their code ever again. So this gets really tried out, which is also very motivating for the students. And yeah, so now that you have all of these numbers, let's consider that there's only 2 of us. So Lucas and I are doing this course right now together, and the reason that we're still able to smile in that picture is that we found tools and workflows that help us tackle these numbers and scale the course to a certain extent, that we can do it and organize it with a reasonable amount of effort put into it from our part. So we're going to give you an overview now how we do it with the Atlassian stack. This being a development project course, obviously some key activities are agile development, source code management, delivery management, and as it is built very heavily on teamwork, there's quite a lot of communication involved also. And we found Atlassian tools to support us in all of this. So we use Jira, what Jira has been originally intended to be used for mostly. We use it for iteration planning, progress tracking. We use Bitbucket Server for this merge request, so this additional quality gate to let more experienced developers check the code of less experienced ones. We use HipChat very heavily for informal communication within the teams and in between teams and within the whole course also, and Confluence for more formal knowledge management. And then we have Bamboo for continuous integration and continuous delivery. But I'm going to hand over to Lucas now to explain a couple of use cases out of these key activities now for you in detail.
Okay, thanks, Dora. So hello from my side. What I will do, I will show you a couple of use cases which show how we use the Atlassian stack to increase the manageability and scalability of this course. So as Dora presented, we're doing this course with over 100 students, and we want to teach them software engineering as realistic as possible. And I want to show you some examples. They are not necessarily related to each other. They're just examples how we apply the Atlassian stack during this course. The first use case is about workflows. So when you think about our Agile project course, we have 10 plus teams developing software together with customers at the same time. But you can also think of you in your organization, you will also have a couple of projects running at the same time. And it's only 2 of us in this course. So when we want to teach a workflow to all the students, we have to think about how to teach these workflows and by keeping it manageable. So we have to think about what have the projects in common, so what things can be pre-configured to the teams and what things need to be adapted by each of those teams. And I will give you one example for that, for a workflow which allows standardization. So this course we are doing, it's heavily based on continuous delivery. We want the students to deliver their code as often as possible. So we want them to deliver their code every second week to their customer, for their customer to give feedback on their work. And for that, we will pre-configured a workflow using the Atlassian stack for them to deliver mobile applications to their customers. So every team who is starting the course gets introduced to the workflow. I will just give you a quick overview of the workflow. So we have these developers, they commit code to a repository, nothing special about that. We have the role of the release manager. So every of the student teams is staffed with one release manager. Is a student who is taking additionally the role of the release manager, taking care about continuous delivery, continuous integration. He's taking care of the integration server. This integration server gets notified on every change the developer of the student team is committing. It's building the application, running the tests, notifying the developer about the status of this build run. And when a build was successful and all the tests succeeded, the team can decide to deliver this version to their customer. So we are developing mobile applications, so we have to upload the application to some kind of a private app store. This is this delivery server. We notify the customer about the next version which is available. The customer can download the application to his device, can test drive it, and he can give feedback. So we include certain feedback frameworks in the application. The customers can just click on one screen and tell me, okay, I want to have this in another way. I don't like that control. And we take this feedback together with crash reports. So it's software in development that tend to crash. So we take the feedback and the crash reports and put them all back to the issue tracker. The developers get notified about that, and the loop starts from the beginning. So this is the loop the development teams will go through multiple times. Let's map this to the Atlassian tools. We have Atlassian Jira here. We have Bitbucket Server as a repository. We use Bamboo as an integration system, and a third-party app store called Hockey App just for the delivery of mobile application. So this is a workflow how we teach it to the students. And when we teach that, we have to think about what kind of knowledge we spread to what group of people. And for that, I brought this iceberg. If you have been to the keynote, and they had a nicer iceberg, but this one will probably do his job. So when we want to teach continuous delivery to students, we first have the group of developers. They don't need to know how a build will be done on command line, every single part of a build script, all the automation. They need to know how to apply the tool, what the workflow is all about, how we should do that in a team, and if an error occurs, how you can take a look at the build log and fix the error as soon as possible. So this is the amount of knowledge I have to teach to every single student in the course. As I said, every team in the course is staffed with a so-called release manager, and they need to know more. So we put all these release managers in a meeting, and we teach them about how to configure deployment pipelines, what it's all about, how to execute tests on that, so they know more, and they are able to adapt the workflow we gave them to their team's needs. And last but not least, we have this role of the workflow manager. This is Dora and I. We do these things since a couple of years. We know a lot of the errors which can occur, so we are the consultants helping the release managers adapting the workflow to their needs. So this was an example, like we do it with continuous delivery. We do that with multiple workflows, like code reviews with pull requests. We always use the same system, having things we teach to everyone, a dedicated role in the team, and us teaching this people with the dedicated role, the workflow. So that's it for the first use case. Let's jump over to the second one. Unrelated to the first one, but when you think back to your university years, you all had to do programming exercises probably. So somebody gave you a piece of paper, do that, maybe you have to write it by hand, maybe you have to commit it to some kind of version control system. When we do our Capstone course, it's about agile software development. To do agile software development of mobile applications, you should be able to program. So what we're doing, we do a 5-day introductory course before the actual Capstone course starts. So 5 days where we introduce all our 100 students to programming, in our case it's Apple's iOS platform, to the development of mobile applications on this platform. And during these 5 days, 1,100 exercises are done. So every student has to finish, you can do the math on your own, 11 exercises in this example. So we have, in 5 days, over 1,100 exercises, and they all need to be corrected. So there would be option 1, Dora and I sit in a room and do it on our own. It will take 4 weeks and we would go crazy. So not an option. What we are doing, we're using tools for that. So let's map it to the Atlassian stack. First, we're using Bitbucket Server. We make use of Git branching. Think of every student creates a new branch for every exercise he needs to do. He commits his solution to this branch, and then we use a pull request to manage the actual review of the exercise he did. So during this week, we have 1,100 pull requests for every exercise, another pull request. Then it's us instructors. We can't take a look at all of those pull requests, but we want to have an impression how the course is progressing, how the exercises are going, if there is one too complicated, one too easy. So we use Jira Agile for that. There's a nice thing, maybe you saw that already. You can trigger issue transitions in Jira out of Bitbucket Server. So for example, a student creates a branch. The corresponding issue is transitioned from open to in progress, so he started working on it. Or another example, a student, a developer, creates a pull request. The issue automatically transitions to in review. So there is a mapping between actions happening in the version control in Bitbucket Server and in Jira Agile. And we are using Jira Agile to monitor the progress of these introductory courses. But still, 1,100 exercises to be corrected. Somebody needs to do the work. So what we are doing, we use a distributed correction approach. We hire 10 student assistants. The student assistant help us reviewing all these pull requests, not by just looking at the code and typing some things like remove this line, but by actually talking to the students. So we're using pull requests and these review cycles to monitor the process and to structure the process, but still it's more all about talking to people in person and teach them how to improve their coding skills. I have some examples for you how this looks in the tool. So this is in Jira, just a Kanban board, pretty simple one. The first thing I can do here, I have a grouping. So it's a simple JQL query. It groups all the issues sent to the students by exercise. So I have exercise 1 to 5 here, and I can take a look how the course is progressing. Is there an exercise where a lot of students have problems submitting their solution? Maybe I did something wrong. So the exercise I brought to the students was too complicated or not clear enough. And I can have a look if there is an exercise with a common mistake, so if something went wrong. I can see that with just one view at this Kanban board. But most important here, I can see who needs help. When I have 1,100 exercises, I have no clue who needs help. But with this, I see most of them submitted their exercise. It's in review. Somebody's taking care of it. But 2 of them haven't even started. Or haven't started filing their pull requests. So I can take care just of these 2 students who had problems finishing the exercise. This is really helpful for us because we can't take a look at 1,100 exercises at the same time. I can then drill down. So this is a view of all the exercises to be done by 1 student. I see he needs to do this 9 exercises here, session 01 to session 09. And some of them are already closed, so the pull request is merged. Some of them are in progress. He needs to start a pull request. Some of them are in review. And I can take a look at, let's have a look at session 09. And I can drill down from the issue sent to the student to the actual pull request and the code. So I can see who is the assistant reviewing the code of the student, what were the comments, what's the problem at the moment? Is the student too slow responding to the feedback? They had no idea how to respond to the feedback. Was maybe the review too slow? So I can just drill down from a Kanban board, from this high-level overview, down to the actual code using Bitbucket Server and Jira Agile, which is a really great help for us managing this programming introductory courses. Okay, talking about high-level overview, drilling down to certain teams, which brings me to my third use case. It's about using metrics to increase the manageability of this project course. We did the following. So we have the 11 teams, and we introduce workflow to these teams. We teach them how to do code reviews. We teach them how to apply continuous delivery, continuous integration, and so on. And we want to get an overview how the workflows are adopted in the teams. So, for example, if there is a team which has problems adopting such a workflow. And second, we want to see, we improve these workflows every semester again and again, if something we changed in the workflow in the last term helped us to improve the adoption. So get a high-level overview on the workflows and also see how our improvement of the workflow went through the teams. For that, we're doing a metrics sheet. So we're generating a metrics sheet of every project team every week. This is just using the REST APIs of all the Atlassian tools and putting all the data together. So it's no standard functionality. We're using the REST API to pull data from all the Atlassian tools and merging them together in this one A4 pager. I'll give you one example how we do that. Let's have a look at continuous integration here. We use a really simple metrics that's the time to fix. So when we teach the students the workflow, the first thing we teach them is after you commit the code, you make sure the build was successful. So time to fix is a nice measure to measure the time between there was a build which failed, so test failed, some artifacts were missing, the build failed, and the first build which is successful afterwards. So we measure the time the team took till a failed build and the first successful build. And when we look at that, at 3 days between the failed build and the successful build is for sure bad. We have to see what was the problem. A time to fix of 0 or 1 hour, it's not necessarily good. When every build was successful, we also could take a look if they have a good test coverage, if they ever wrote unit tests. So we are still talking about a teaching environment. So we can use these metrics as a first thing to have an overview and then can drill down to the actual teams to look if there is a problem or everything is working nicely. To verify this time to fix, we also measure the amount of builds done in the last week and see how many builds failed compared to the successful ones. If there was just one build, the team haven't done that much work, you don't have to take a look at the time to fix. Because we use this metric sheet to see if people and teams adopt our workflows and to talk to the teams if we see a problem here. We also take a look at the time to fix over time. So let's see here, for example, in week 5, we saw the time to fix increased. We talked to the team and we had a look what was the problem. And afterwards, we just monitor how the time to fix evolved over time to see if they adopted our feedback or not. So we can talk to them again or everything went fine. That's it from my side, and I will now hand over to Dora.
Yeah, actually, there was another use case that you were supposed to present. I wrote you an email about it this morning.
Yeah, but as I said, I don't read email. Never.
Which is exactly what we tell to our students when they tell us that they wrote us email, because we actually managed to get rid of email altogether. And we're really, really happy about that, because if any of you ever try to have a meaningful discussion with 8 to 10 people over email, you know that it just doesn't work. And there's even worse things that happen when a team doesn't have any other communication channel other than email. because they will try to find all of these loopholes and create these small impromptu channels like Facebook groups, text messages, all different chat clients, or they go back to email, and it just doesn't work. So a year ago, we told them no more email, no more mailing lists. All communication in the course is done via HipChat. And the transition was surprisingly easy, and the students adopted it really well, and we never looked back, and we really love it. Overview. So we didn't give them a blank HipChat space. We gave them some kind of structure. We mapped the organizational structure of our course in HipChat. So we created some rooms, and then they're free to create their own ones and adopt it to their way of working as they like. But first of all, we created rooms for the whole course, where students can rooms private to projects, where only the developers and project leaders of the project are members, and only they can see it. And then we did also overarching rooms for the whole course for engineering topics like modeling, code quality, continuous delivery, which are worth discussing in between projects, but only with people who are interested in that topic or working on the topic currently. For example, we introduced this lobby, which you see there at the second in the list, where people can just do some Q&A. So developers can ask each other questions. Hey, what happens if I get this compile error? What could I do to fix it? And we found that quite often we don't even need to do anything to solve their problem. They just solve it by themselves, which also takes quite a lot of work off our shoulders. And they kind of feel good helping each other. Another thing that works really well in HipChat for us is mapping this informal communication channel to management, which we do in Confluence. So for each of these rooms, we've linked the corresponding Confluence space right there. And whenever they want to share something that should be stored permanently, they Confluence, and then they can come back and discuss it here in HipChat. And you will have the notifications going back and forth. So this has been working really well for us. Our teams also do the complete documentation in Confluence collaboratively. Another very good or very large advantage of HipChat is its potential to abstract and to simplify. So this continuous delivery workflow that Lucas presented just a minute ago, use case 1, it's summarized here in this one green line. If the build that you did was you don't need to go check Bamboo, everything's fine, you can just continue your work, and your team also knows that everything's going great. If that's red, then you can click in there, go into the corresponding tool, and check out what you need to do to get it running again. But as long as everything's going okay, it saves you a lot of time, it saves you a lot of complexity, and you just don't need to do any additional work. So this has been working very well for us, and we really like HipChat. Now, this is all from our use cases, even the ones that got sent via email today. We want to try to summarize what we learned, because all that we talked about today, this didn't get done in a day or even in a month. We've built up this infrastructure and these workflows during the last couple of years, and we keep on improving and assessing what's not going wrong, what's not going right, and also responding to feedback from the students. And we made some very, very valuable experiences and also mistakes over the years. And one thing that we became aware of is that, as tacky as it sounds, when you design workflows for multiple projects and you're doing project management, you need to ask yourself this one question: does it scale? product who then uses them. And they take the workflows that we give them and adopt it to their teams and make jokes about it and work really hard during the night, and then are happy that they learned the tools and that they learned to work as a team and really take something away from it. So it's also a lot of fun. And if you have any questions or any feedback, we're happy. We're constantly improving, and we will be around now or during Meet the Speakers tomorrow, and you can just come up to us and talk. But sure, should I read the first one? Yep. The first question is, are you making an effort to share this course structure with other universities and colleges? You want to?
Yeah. To other universities in the region. What we also do, we are regularly on conferences. We did a tutorial on the course, and we also publish papers on it. So it's not like, okay, this is ours and we do it great and we don't tell anybody. You can even just look up papers on the course and how we set it up in every detail with organizational charts. And if you want to get more information, write us emails. We were happily to share. Or HipChat. Or HipChats, yeah. we happily invite you.
Okay, to find companies to contribute problems that would fit the scope of the course and collaborating with the students. I think I'll take this one.
Yes.
So, well, Munich being the IT hub that it is, it's not very difficult to find the companies as such. They usually come to us by now. And what's difficult sometimes, or a bit tricky, is to nail the problem down to something that can be developed in the course of 3 months. We often do innovative projects that end up with a very usable prototype that prove that kind of use case can be done. We've done a lot with sensors lately, or Apple Watch, and so that's kind of more the tricky part, not finding the companies, more finding the interesting projects to work on. Should I do another?
Yeah, there's a couple more.
Yeah. Does your university IT department support your development environment? Do your students get real-world experience in working with IT?
That's a really good one. To be honest, we're hosting the whole Atlassian stack on our own. So we have admin staff at the chair, and it took us years to manage this finally, so to get everything up and running, that it scales during the course. And so we do the full thing, from doing the actual system administration to teaching the student how to use the tools. As it grows bigger now and it gets exported to other universities, we are thinking about either moving the whole thing to the cloud or hosting it centrally. But right now, we're basically doing the full thing at our chair with some assistants and administrators.
Okay, should we do maybe last one? What interesting projects have you attempted in your course? There's so many different ones. Do you have one particular one? Otherwise,
so at the moment, maybe I talk about the project I'm doing. Yeah. So we're working with a pharmaceutical company in the area of diabetes management. And it's all about mobile applications. And it's never just a mobile application. It's always something plus. So at the moment, we're doing a project with a couple of students. They maybe watch this thing on the website later on. We're connecting blood sugar meters to mobile devices, try to find new use cases for that, try to collect data from various health trackers inside one application and improve the life of patients with diabetes. Or the next project is dealing about incident management of cars and what to do if you are on the street, you had an incident with your car. The use cases really vary from car manufacturers to pharmaceuticals to holiday providers. If you are interested,
we also have one which is called the intelligent washing machine, where it's about proving that putting quite cheap waterproof RFID tags on the washing machine can help the washing machine to recognize what kind of programs to use, or for example, alert the user if they're a student and don't know how to do their laundry, to not put that one red sock in with their whites, or the one delicate t-shirt in with all of the other clothes on a high temperature.
You can Google our names. We have videos of all the projects we did in the last years. So the projects are always led by a PhD student of the chair. You will find them in the web. There are around about 50 now.
And the students also do very funny demos at the final presentations. We do it very demo-driven. So, for example, there was this fitness application. It was about collaborative fitness in the workplace. And they kind of just played this fitness song and did some collaborative exercises with 200 people present. It was a lot of fun. So they really have a ball. Yeah, thank you.